Assalamualaikum warahmatullahi wabarakatuh. Good morning to all my students. So today I'd like to share or discuss with all of you, explain to all of you the content of chapter 3 numerical method, where we look at here the first 3.1 solution of nonlinear equation, 3.2 Newton-Raphson method, and also 3.3 trapezoidal rule. Okay, so I do believe that all of you are holding your lecture notes with you right now. Okay. So then we look at the first part of this lecture, looking at the solution of nonlinear equation and also Newton-Raphson method. Okay. We can easily find the roots of the equation of, let's say, x squared minus 5x plus 6 will be equal to 0. Then we factorize, which is x minus 3 and x minus 2. So we can simply get the roots of this equation, quadratic equation here, which is x equal to 2 and x equal to 3. Okay, so then 3.1 solution of nonlinear equation. This case is where you cannot find the roots of the equation easily, as I showed you here. Okay, locate a solution of nonlinear equation. First, we're going to locate approximately a root of an equation by graphical consideration or searching for a sign change. Searching for a sign change. And also here mentioned here is by graphical consideration or searching for a sign change. And Newton-Raphson method, find the root by Newton-Raphson using the formula of this. Okay. So then, numerical method can be used to find the approximate solution for nonlinear equation and also the approximate values for the definite integrals. So there are two situations here, solution for nonlinear equation and also the approximate values for definite integrals. Definite integrals. Okay, this one we're going to look into at the second part of this lecture. Now, first, we are concentrating on this part here now. Okay, example, 2 sine x minus x equal to 0. Okay, as I share with all of you just now, if given to you an x squared minus 5x plus 6 equal to 0, then we can simply factorize this, where x minus 3 and x minus 2. So we come up with a conclusion that which is x equal to 2 and x equal to 3. So these are the roots of this quadratic equation. But what about this one here now? So then what about this one here now? 2 sine x minus x equal to 0. Then we can use using Newton-Raphson method, okay, to find the approximate value of x. Okay. And also for question example of B here, integral of e power of x squared dx. Where in this case we just thinking of how are we going to solve this. We cannot use the integration by part. We can't use substitution or the other methods that we learned previously in chapter 2. So then, for this question, we come up with another solution. We're going to use this method of numerical method using the trapezoidal rule. Okay, using trapezoidal rule for this one here now. Okay. Now, example 1. Okay, So x squared minus 4x minus 5 equal to 0. So we factorize, then we come up with a conclusion where x equal to -1 or x equal to 5. The exact roots of the equation, just like the example, previous example that I shared with all of you just now, where I wrote with a pen. Okay, and then what about this one here now? So x cubed minus e power of x equal to 0. This is a most nonlinear equation that have no exact root, meaning that we cannot simply say that the value of x equal to might be 1 or 2 or round figures. No. So then we come up with a solution in decimal form. Okay, so for solution of nonlinear equations, there are two methods, graphically and algebraic. Graphically means that we need to sketch a graph. And this case might be involved with two graphs, so that sketch a graphs. Okay, and so do you still remember how to sketch a linear graph, quadratic graph, cubic, square root function, square root graph? What else? Natural log, graph of log, and also the exponential function. Okay, so please refresh, ask yourself whether you still can sketch all this kind of graph, because we need it in this part. And algebraic, meaning that we look into the equation of this one here just now. Okay, how to find initial approximate value or the first approximation? Okay, so in this case, finding an initial approximate value for the first approximation, by graphically or graphical method, we sketch the graph of y equal to fx. Then, the real root is the point where the graph intersects at x-axis. Or, rewrite fx equal to 0 to a new form of hx equal to gx. Let's sketch the graph of y equal to hx and y equal to gx, and the real root is the point of intersection between the two graphs. An algebraic method, find two values of a and b such that fa and fb have different signs, and at least one root must be lies between a and b if fx is continuous. So then, first, let's take a look at this one here now. Locate the approximate value. Okay, locate the approximate value of the equation of this here now. So, from natural log of x plus x minus 2 equal to 0. Okay, so please refer to the previous notes. Okay. Rewrite fx to a new form of hx equal to gx. So, do you have any idea how we're going to form into hx and gx from this one equation? Okay, my idea, let's bring this to the other side. A natural log of x equal to 2 minus x. Okay, so let's imagine this one as we call hx and gx. Okay, we define this hx equal to natural log of x and gx equal to 2 minus x. And next, we are going to, using the graphical method, now let's sketch the graph of this. Okay, so let's sketch the graph of this first. natural log of x. Natural log of x when x equal to 0, when x equal to 1, natural log of 1 equal to 0, meaning when x equal to 1. When x equal to 1, 1 here, and natural log of 1 equal to y equal to 0 here. And then when x equal to 0, natural log of 0 or log 0 is undefined. Okay, and then let's say let x equal to 1 over 2. Okay, let's say if I imagine that what's going to happen to the graph if x equal to 1 over 2 here. Okay, natural log of 1 over 2. Okay, I use the calculator here. 1 divided by 2. It is negative. Okay, it is negative here. Meaning, when x equal to half, y equal to negative. So we imagine that the graph of log x, okay, this is hx equal to natural log of x. Okay, I change the color of the next graph here for 2 minus x. Okay, never mind. For gx equal to 2 minus x when x equal to 0. When x equal to 0, gx or y equal to 2. And when gx or y equal to 0. Okay, so let's we can imagine it here. 2 minus x equal to 0, then negative x equal to negative 2, then x equal to 2. So that x equal to 2. Okay, let's find out now the coordinate of these two. X 0, y equal to 2. Somewhere around here. Okay. And then when x equal to 2, y equal to 0. Okay. So I'm just trying here now. Oh, I can sketch. Oh no. Okay, something like this. Okay. There you go. Okay. This is a line of gx equal to negative x plus 2 or 2 minus x. Okay, now, this is the intersection point between the graph of hx and gx. So, can you imagine, or give me an idea. What is the value of this accurate value? Nope. Okay, there is no accurate value, but we can just estimate, okay, the approximate value. We can just only estimate the approximate value approximate to 1.5. Okay, in between 1 and 2. So, the approximate value is x equal to 1.5. There you go. Okay, it can be 1.3, it can be 1.2 or 1.4 or 1.35. It's all up to you then. Okay, so if you're saying that this one is 1.35, it's still correct. 1.45 is still correct. As long as you can see here, you can just estimate this point very close to 1. It's not even half. It might be 1.25. So it's all up to you. Okay, because the question did not state the value of x, so we can decide by looking at the intersection point between these two graphs. By drawing stable graph, find the initial approximate value for 7 cos x minus x equal to 0 for x lies in between 0 until 2 pi. And again, 7 cos x minus x equal to 0, then 7 cos x equal to an x. So then fx equal to, we define this as an fx. Okay, so if I define the next function as an gx equal to 7 cos x and hx equal to an x. Okay, y and x. So the first, which I think that is the easiest one here, hx equal to an x or y equal to an x, meaning that the graph should be something like this. No, is 45 degrees from between the x and also y axis. So how can I say that? Yeah. There you go. Okay, just assume that this is hx equal to an x, which is 45 degrees between the line to the x-axis and 45 to the y-axis. Just imagine it. Okay, and then the graph of 7 cos x. The graph of 7 cos x. Okay, you may use any apps that you have, or let's say if I sing this one here now, which is pi over 2, pi, 3 pi over 2, and also 2 pi. Okay, you may use, find the graph of this using your apps in your smartphone, or you may search, go to the website of www.desmos.com. Okay, this is only Graphical website that I know. You might know better than me. Okay, it's all up to you then. And now, let's say the graph intersect at this point and here. There you go. Okay, so this is the graph of gx equal to 7 cos x. Okay, now the intersection point between these two, and also here. Okay, so you may come up with your own conclusion. So I just referring to the notes. So then the approximate values of x values are in between 0 until 0 pi over 2. You may just rough you can just decide on your own. So for me it's a pi over 4 and between 3 pi over 2 until 2 pi. Okay, so here is 7 pi over 4. Okay, as I said, that is just approximate value. Okay, find in your find in the dictionary what's the meaning of approximate. Okay, approximate values meaning that any values that are really close to the roots of the x, root of the function. Okay, by drawing stable graph, find the initial approximate value again. Find the initial approximate value for this one here now. X squared minus 2e power of negative x equal to 1. Okay, so then we come up with x squared, bring this one to the left side, minus 1 equal to 2e power of negative x. So then we come up with gx equal to x squared minus 1 and hx equal to 2e power of negative x. Okay, again, sketch the x-axis. Y-axis and also x-axis. Okay, the first one here now, 2e power of negative x, e power of, okay, let's say x equal to 0, and please refresh our memories about sketching graph of exponential in chapter 5, function and graph in semester 1. Okay, when e power of negative, okay, e power of x. E power of x, the graph is something like this. So oppositely, if e power of negative x, then come up with this one here. And when x equal to 0, e power of negative 0 equal to 1, 1 times 2 equal to 2. Intersect y here at x equal to 2. Y equal to 2. Okay, so then next one here now. Okay, and next one, the graph of x squared minus 1. X squared minus 1, gx equal to x squared minus 1, where we factorize this, come out with x minus 1 and x plus 1, where it is x equal to plus minus 1, meaning here and here, negative 1 and 1. And when x equal to 0, y negative 1 here. Okay. Something like this. Sorry. Okay, now try again. Sorry. Okay. Negative 1 and 1. And now, the intersection point between these two, okay, so I think that I need to make some adjustment here. If, let's say, this graph did not meet each other, then okay. Everyone, I'm sorry for that. We call bad sketching on that. Okay. So, what is your suggestion for this value of x? The initial approximate value of x squared minus 2ex minus 1. Okay. You may say that it might be 1.3, 1.2, or 1.5. So if I put this one here as 1.5, so then the approximate value is x equal to 1.5. Okay. And now, show that the equation of x squared minus 1 over x plus 4 has a root lies in between 0.2 and 0.3. Okay, has a root lies in between 0.2 and 0.3. Okay, so just imagine that if I take this, okay, as an fx, sorry, fx equal to x squared minus 1 over x plus 4. Okay, so we are going to test these two values that we're going to substitute into a function, into an x of this function. And if, let's say, from f0.2 we get a positive value answer, and f0.3 give us a negative answer, there's a change from positive to negative, or the other way around, if we substitute f0.2 that give us negative, and f0.3, and if this one gives you positive, it also changes from negative to positive, either one, okay, from positive to negative or negative to positive. If this happens, meaning we come up with a conclusion that there is a root lies in between 0.2 and 0.3. Okay, so now let's try with f0.2. It's 0.2 squared minus 1 over 0.2 plus 4. Okay. What about this one here now? I'll try. Okay. 0.2 in bracket squared, then minus fraction of 1 divided by 0.2 and plus 4. Okay, I'll try by myself using this one here now. Okay, you use your calculator to setting all this and press the calculator button of equal. It gives us negative 0.96. Okay, and this is negative, which is less than 0. Now f0.3. Now substitute x, these two, with 0.3. 0.3 squared minus 1 over 0.3 plus 4. Okay, so I'll try again. 0.3 in bracket squared minus 1 divided by 0.3 plus 4. Okay, again I get a fraction that I change into decimal. It gives me 0.75666 or 0.57, which is positive, greater than 0. Okay, now class, I mentioned just now, if we substitute these two values into the function of fx, and it gives us one value with a negative and another one is positive, the changes from negative to positive or from positive to negative, either one. So they come up with the conclusion that, say, okay, just refer to this, since that, okay, f0.2 equal give us a value of negative, and f0.3 give us a value of positive. Okay, so thus the equation of fx has a root lies in between x equal to 0.2 and x equal to 0.3. Okay. Next question. Show the equation has a root lies interval of -3 and until -2. So just imagine that this number line with x equal to -3, -2, -1, 0, 1, 2, 3, and so on. Okay, so we like to see whether there's a root lies in between -3 and -2. So that before that we need to test this, and now we form this as an fx equal to x cubed minus 6x plus 7. Okay, and now let's test this function with -3. -3 cubed minus 6 times -3 plus 7. Negative cube, -3 square or 3 times 3 equal to 9, 9 times 3 equal to 27. -6 times -3 plus 18 plus 7. 18 plus 7, which is 25, minus 27 equal to -2, which is less than 0. And f -2, -2 cubed minus 6 times -2 plus 7. There it is. -3, negative cube is negative here, 2 square, 4, and then times 2 equal to 8. -6 times -12 equal to positive 12 plus 7. So 12 plus 7 is 19 minus 8 equal to positive 8, which is greater than 0. Is it 12? -2 cube equal to -8. -6 times -2, 6 times 2 is equal to 12, and then 7. 12 plus 7 is 19. 19 minus -8 equal to an 8, whatever. It's still positive. So then the changes from negative to positive, from less than 0, and the other one is greater than 0. So we write down the previous equal this sentence here, and we come up with a conclusion that there is a root lies in between x equal to -3 and x equal to -2. Okay, now class, we're going to look into the definition of Newton-Raphson method. Just now we substitute two values of x to see whether there's changes from negative to positive or positive to negative. If that happens, means that we come up with conclusion that there is a root lies in between these two values of x. And then we are going to find a better approximation, okay, from the test. After we come up with conclusion that there is a root lies in between x equal to -3 until x equal to -2 just now, then we decide one value of x. We decide one value. And after that, we are going to use that first value into the function that we're going to form here to find a better approximation. Okay, so then here now, repeat this process as required. Okay, for xn plus 1 equal to xn and all this. Okay, what's all this? Okay, we're going to look into an example, okay, to give you a clear picture of this. Find the solution of x plus e of x equal to 0 near to negative 0.5 to 4 decimal places by using the Newton-Raphson method. Okay, okay class. In this question, it straightly gives you the first initial values of x that we are going to use to find the better approximation. Let's say if this value of x is not given to us in the question, then we test this, okay, between x equal to negative 1 until x equal to 0. Let's say because the x here is negative 0.5, so negative 0.5 lies in between negative 1 until 0. Okay, class, again, this is not solution, one of the solution for this question, because it's already gave you this value of x. Just imagine that if this value is not given in the question and they want you to find one of your own initial value of x. So x1 and negative 1 and x equal to 0. So this is our fx. Okay, so f negative 1 equal to negative 1 plus e power of negative 1. E power of x, where x is negative 1, negative 1. Okay, what we're going to get here now? Which I think that negative, okay, this is negative 1 plus with e power of negative, which is 1 over e. Okay, 1 divided by 2.71828. Okay, just imagine it's 0.36. Okay, 0.367. So negative 1 plus negative 1 plus negative 1 plus 1 over so 1 divided by 2.71828 equal to 0.367. So then negative 1 plus 0.367, negative 1 plus 0.367, which is negative. Okay, this one is negative 0.633. Okay, and then f0 equal to negative 1 plus, okay, x equal to 0 plus 1 over e power of 0. E power of 0 equal to 1, so the whole things here become 1. So 0 plus 1 equal to 1. Okay, from negative to positive, the changes we call a sign from negative to positive. So we come up with conclusion that there is a root lies in between 0, negative 1 until 0. So that we can decide, in this question, it decides us to use the x equal to negative 0.5 for the starting of the process. Okay, so this one is just to clarify that there is a root lies in between negative 1 until 0, and negative 0.5 is one of the roots lies in between these two. Okay, now So then here now, fx equal to x plus e to the power of x. And then f prime x equal to, differentiate x equal to 1 plus a derivative of e power of x equal to e to the power of x. Okay, why did I come up with these two? Okay, so let's see again. Because we are going to find a better approximation from the initial value of x, which is x2 equal to x1 minus fx divided by f prime x1. Okay, fx and also f prime x. We substitute with x1, x1, and x1 to get the value of x2. And now, so our starting point here now, which is x0 equal to negative 0.5. So then x1 equal to negative 0.5 plus with x1 minus, so then here now x1 minus look at this one here now, fx which is x equal to negative 0.5 plus e power of negative 0.5 divided by fx divided by f prime x. Okay, this is fx. Here we substitute x and e power of x with 0.5 and then f prime which is 1 e power of negative 0.5. Okay, so use your calculator to get the answers of this. So I strictly use recall the value that we given in the lecture notes and here. So x, okay, in this case they use the first initial of first value of x, which is x1, and here is x2. Some books they use x0. Okay, and it's not a big method here. So x2, calculate using your press your calculator button, then you will get answer of this, which is negative 0.56631. Okay, x3, this is the new value of x that we're going to substitute into the function of xn plus 1 equal to xn minus fxn divided by f prime xn. Okay, substitute here now. So then this is our new value, negative 0.56631 minus fx, negative 0.56631 plus e to the power of negative 0.56631 divided by 1 plus e power of negative 0.56631. Okay, again use the calculator. It gives you x4, which is negative 0.5714. Okay, now we are going to compare between this x2 and x3. This answers of x2 and this is answer of x3. So 566, 567. So we look at the 3 decimal places of these two. We compare 566 and 567. There's a difference between 6 and 7. And we repeat the process again using this value of x3 into the equation to get the value of x4, and here we get negative 0.56714. So look at this one here now, 567, 567, 1 doesn't change we call the numbers of 7 here, and also here 1 did not change to the 7, become 8. It retained remain as at 0.56714. So in this case, we come up with a conclusion that the roots is negative 0.5671. Okay, so the point is, we repeat the process. Okay, we begin here, substitute into this function of fx and f prime is given here. Then we generate one value. Then we use this value, substitute into this function of this one here, and we generate another value. Then we compare. We want it at least 3 decimal places where it is we call repeating, but in this x2 and x3 is not happen, because here is negative 0.566 and here is negative 0.567. Use this formula again to generate x4, and finally we found that it is equal, we call it repeating here, which is negative 0.56714, exactly as the previous of x3. So this is our answers here now. Okay. And now, sure, equation of this here has a root lies in between 1 and 2. Okay, so it means that in this case, we're going to substitute 1 and 2 into here. And once we have proved that by taking x1 equal to 1.6. Okay, class. At one time, it might be they give you a question without an initial value of x, without this value of x1, meaning you can choose any values of your own as long as it lies in between 1 and 2. But then it's already given here x1 as a first approximation that evaluate the root equation correct to 3 significant figures by using the Newton-Raphson method. Okay, now. Okay. Question example 7. Okay. Let fx equal to x cubed plus x minus 6. Okay. And given that lies in between x equal to 1 and x equal to 2. Okay. So let's try with f1. 1 cubed plus 1 minus 6. 1 plus 1 equal to 2 minus 6 equal to negative 4, which is less than 0. Then f2. 2 cubed plus 2 minus 6. 2 cubed equal to 8 plus 2 equal to 10 minus 6 equal to 4, which is greater than 0. So you can see here now that the changes from negative to positive, or from values that less than 0 to a greater than 0. So then there is a root lies in between x equal to 1 and x equal to 2. Okay, so then now from fx equal to x cubed plus x minus 6 and f prime x equal to 3x squared plus 1. So the first value, which is x1 equal to, is given that is 1.6. So x2 equal to 1.6 minus, okay, 1.6 cubed plus 1.6 minus 6, which is 1.6 cubed plus 1.6 minus 6, okay, divided by f prime 3 1.6 square plus 1. Okay, use your calculator. So I just scrape the answers here now. I generate the first one here, x2 equal to 1.635. Okay, this is x2. Now, x1 of course is different here. Okay, we generate another one here, x3. Use this formula, this value of x, substitute into the same equation, but we change the value of x, 1.6350. Okay, 1.6350 minus 1.6350 square plus 1.6350 minus 6 divided by 3 times 1.6350 square plus 1. And for x3, you will get here 1.6344. Okay, you compare between this and this 1.6350, 1.6344. So because 5 will change this 3 to 4. 4 doesn't change this 3 here to become 4. Okay, it retains with the 3 here. So their 2 are not repeating, as we recall. It's not repeating here. So then x4 again, you substitute value here and it gives you 1.6344. You may form this in your calculator, then you can just substitute the value of x from one to another one. Okay, so you can see here now 1.63, 1.63, 4 and 4, 4 and 4. So it repeating here. Then we come up with the conclusion that x, the root is 1.63. Okay, we continue. So that the equation of this x minus 1 equal to sin x has a root lies in between 1 and 2. Okay. And by taking 1.7, which I think that this example exactly most the same as example 7, if I'm not mistaken. Okay, where from here x minus 1 equal to sin x. So then make it this one as a x minus 1 equal minus sin x equal to 0. So this is our fx. Okay, x minus 1 minus sin x. So then f prime x equal to differentiate x equal to 1, derivative for 1 equal to 0, minus differentiate sine equal to cos x. Okay, but before that, from this fx, you need to prove that, show that the equation of this has a root lies in between 1 and 2. So class, because this example exactly the same as example 7. So I just give you the clue. Substitute with f1 and also f2. Okay, you may test using the calculator. Then I gave you this one is supposed then here, which is negative. You find the answers by yourself, and this one is positive. Okay, and then fx and f prime. So x1 equal to, given here is 1.7. So then x2 x1 minus fx divided by f prime x. So generally, then you will come up with the conclusion that the x we're looking for here is 1.935. Okay, so try by yourself. Okay, because It's almost 1 hour. I'm not going to make it longer for the same example. Okay. Okay, now let's take a look at this one here now. Approximate cube root of 7 by using Graphical method. Initial value of 2. Initial value of 2 meaning x1 equal to 2. Okay. So for this case, the solution here, okay, the solution, let x equal to cube root of x, or cube root of 7, sorry. Okay, and then make this one here. So x cubed equal to 7, then x cubed minus 7 equal to 0. So this is our fx, which is x cubed minus 7. Okay, so then f prime x equal to derivative of x cubed, 3x squared. Okay. Okay, fx and f prime x, so then let x1 equal to 2. So x2 equal to 2 minus fx. Fx here, which is x equal to, first here is 2. So 2 cubed minus 7 divided by this one here, f prime x, 3, and x equal to 2 squared. Okay, you may use a calculator and you'll get here, which is 1.91667. So then x3 equal to, use this value here now, 1.91667 minus, okay, 1.91667 cube minus 7 divided by 3, 1.91667 squared. Okay, so if this one give you 1.91294 up to second iteration. So 91 and 91 here. Oh, sorry. Up to second iteration, which I think that is one here, 1.9. Okay, look at this one here. After 1, which is 6, which is greater than 5, and we change this one into 2. And 2 doesn't change the 1 to become 2. So 1.91, 1.91. So then here now, the value of roots of this equation of x equal to cube root of 7 equal to 1.91. Okay, to 3 significant figures. Okay, so now using the calculator, find the approximate of this x1. Okay, iteration function here, and key in. You may test this by yourself at your hostel. Okay, so give us, we call the answers of this one here, and another one, 1.912 all this. So this is our conclusion. Okay, now, so the conclusion here, graphical method for, we call the first part of our lecture for this time. Okay, and not going to, we call, re-explain all this because we discussed a long time, we call from the beginning. And if you like to find the approximation to a root of the fx, we use all the, we call this one here, and repeat the process as required. Okay, so I think that's all for today. And till meet again, Please don't forget to continue with your tutorial and PSPN question. Assalamualaikum warahmatullahi wabarakatuh and have a nice day.